So a piecewise function is a little bit like building a puzzle because we use little parts of various functions to describe what's happening at different times or in different parts of the graph. So let's have a look. The following two equations represent the distance traveled by a group of hikers over 5 hours. Equation 1 represents the first section of the hike when the students are walking at a pace of 4 kilometers per hour. Equation 2 represents the second section of the hike when the students change their walking pace. So equation 1 is d equals 4t. And that's pretty cool because we can see that our gradient of that line, it's a straight line, is 4. And their walking pace is 4 kilometers per hour. And they say this is valid for time from 0 to 2 hours. In equation 2, d equals 2t plus 4, so we still have a linear function, and that is for hours 2 to hours 5. The variable d is the distance in kilometers from the campsite, and t is time in hours. And the first part of it says determine the time in hours for which the group traveled in the first section of the hike. Now the time in hours is going to be our domain for which our first section of the hike is. So our domain there says it's from 0 to 2, so therefore they traveled at 4 kilometers per hour for 2 hours. All right, B. What was their walking pace in the second section of their hike? Well, that's going to be the gradient of that graph or that function. So there we have 2t. So our pace will be 2 kilometers per hour. And for how long did they walk? Well, that says from 2 to 5. So there our domain is going to be 2 to 5 hours. So they walked at 2 kilometers per hour for 3 hours. All right, now they want us to write the two equations as a single piecewise function, sketch it to represent the distance traveled by the students over the 5-hour hike. Now, we know that these two functions may or may not intersect, we don't know, but we know that we're only going to draw this one up until 2 and this one from 2. So we need to find our intersection point and then decide whether these things actually do intersect, if they don't, and what's happening around about t equals 2. Okay, so let's have a look to find our intersection point. We're going to solve simultaneously. Okay, so we have d equals 4t is our first equation, and d equals 2t plus 4 is our second equation. I'm going to substitute 1 into 2, and we have that 4t is 2t plus 4. So 2t is 4 and t equals 2. And we're going to substitute t equals 2 into 1. So d is going to be 4 times 2, which is 8. So my point of intersection is going to be at 2 and 8. All right. Now, I need to know where these things start and end. So the start of my first hike is when t equals 0, and we're using the equation d equals 4t, so d equals 0. So I'm starting at 0, 0, and I'm going up to 2, 8. And then I need to know the end of my second hike, because 2, 8 is the start of my second hike. So end of my second hike is going to be when t equals 5 hours. And d is going to be, now I'm going to use my second equation, 2 times 5 plus 4, and that's going to be 14. Okay, these are both linear. I only need 2 points for each one. Let's go with it. So we have 0, 2, 4, 6, 8, 10, 12, 14, and you have to go up as high as 16, and this is going to be distance in kilometers. And my time, 1, 2, 3, 4, 5, and this is time in hours. And I know that my first part of my hike starts at 0, 0 and ends at 2 and 8. So my first line is up here. And then my second part of my hike starts at 2, 8 and ends at 5 and 14. So my second part of my hike is over here. Now they finish hiking there, so 14 is included. So I'm going to put a filled in circle there, and I'm going to put a filled in circle over here. This is d equals 4t, and this one is d equals 2t plus 4. And then they want us to write this as a single piecewise function. So that means I'm going to put them together. So f of x, and I'm going to use a curly bracket to hold them together. First one is 4t for x is greater than or equal to 0, less than or equal to 2 hours, and 2t plus 4 from 2 to 5.